Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 16 practice questions that should closely mirror what you'll see on the Mathematics Knowledge Subtest of the ASVAB as well as the PiCAT. If this is your first time finding my YouTube channel, I quickly want to mention this. You can take this practice test on my website, and my website's called asvabapp.com. More specifically, you would click on the 6th full-length AFQT practice test. If for some reason you don't want to go to my website and take this practice test, you're more than welcome to follow along here on YouTube. And if you do that, I strongly encourage you to pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. Just as a reminder, you're not permitted to use a reference sheet or a calculator on the ASVAB. So if you're going to take this practice test here on YouTube or even on my website, try not to make use of any of those resources. And finally, I want to mention that in the description of this video, there are going to be timestamps associated with each question. Next to the timestamp is going to be the topic that the question's testing, as well as a link to a video in which I discuss that topic in greater detail. So if for whatever reason you get stuck on one of these problems, just go to the description of this video, look for the topic, and then watch the video about that topic. So all that being said, let's go ahead and get started with today's video. All right, this first question says if x plus 4y equals 21 and y equals 3, then x equals. All right, so on the ASVAB, you're going to have scratch paper. And in light of that, I encourage you to write down these problems on your scratch paper. So we have x plus 4y equals 21, and we're told y equals 3. So this question's just testing your ability to substitute whole values in for variables and then solve the equation accordingly. So let's go ahead and do that. We have x plus 4. We're told y is 3, so we'll plug in 3 in place of y here, equals 21. This becomes x plus 4 times 3 is 12, equals 21. Again, we're trying to solve for x. This x equals means x equals. That is, we want to have x on one side of the equal sign by itself. So to do that here, we're going to subtract 12 from both sides. This will cross out, leaving you with just x equals. And let's go ahead and work this out if you can't do it in your head. 1 minus 2 we can't do, so we have to borrow. This becomes 1, this becomes 11. 11 minus 2, well, that's 9, 10, 11. So this is 9. 1 minus 1 is 0. So x equals 9 in this case. All right, so that's that one. Again, typically the ASVAB starts out with very easy questions and it progressively gets more difficult, depending on how you do, of course. So make sure you can substitute values into equations and solve for the missing variable accordingly. That is a very common question on the test. All right, and as we saw, the answer was A, so let's go ahead and circle it. All right, number 2 says, what are the factors of x squared plus 4x minus 32? Not surprisingly, I'm going to start this one by copying it down. X squared plus 4x minus 32. And all we have to do is factor this one. We're factoring a quadratic equation that has a leading coefficient of 1 here. So we know when we factor it, it's going to look like this, x, x, and then we have to decide what comes here and here. Well, we're looking for two factors that multiply to negative 32 and add to positive 4. Well, I know that's going to be negative 4 and positive 8. Again, negative 4 times positive 8 is negative 32. Negative 4 plus positive 8 is positive 4. So these are our two factors, and we can see that those are answer choice D in this case. All right, number 3 here says, what is the area of a parallelogram if it has a base of x plus 5 and a height of x plus 3? So on my website, there's a 13-page reference sheet, and I strongly encourage you to learn and memorize all the formulas on that reference sheet. And if you look close enough, you'll find the formula to find the area of a parallelogram, and that is pretty simple. It's area equals base times height. In this case, we're given our base and height. We're told the base of this parallelogram is x plus 5, and its height is x plus 3. So all we have to do is plug those two values into this equation and solve accordingly. So area equals, our base is x plus 5, and our height is x plus 3. All right, unfortunately, that's not one of our answer choices. So in light of that, we're going to have to expand this via either the FOIL method or the distributive property. Those two things are the same. So the distributive property says take this x and multiply it here and here. Then it says take this 5 and multiply it here and here. So that's what we're going to do. As you can see, we have x times x to start, which is x squared. Then we have x times 3, which is 3x, so this is plus 3x. Then we have 5 times x, which is 5x. And then 5 times 3, which is 15. All we have to do now is combine our like terms. Again, there's no like term of x squared here, so we'll just drop that down. 3x and 5x are like terms, so we'll add those. 3x plus 5x is 8x, and then just plus 15. All right, so the answer to this one is x squared plus 8x plus 15, which is answer choice B. All right, so you really didn't have to know too much about parallelograms apart from the fact that their area is found by multiplying base times height. And then you had to know some basic algebra here to expand your answer choice accordingly. All right, so that's it. All right, so number 4 here says, what is the sum of 2x squared plus 3x minus 7 and 3x squared minus x minus 10? This problem is testing your ability to add two polynomials. And let me say this. I recently created an hour-long video regarding like terms and adding and subtracting polynomials. These questions on the ASVAB get more complicated than this one. So if you struggle with adding polynomials, please go watch that video. I think I work out about 20 different practice problems. And if you watch that video from start to finish, you should have no problem answering any of these questions on the ASVAB, and you will get a question like this on the ASVAB. I'll almost guarantee that. But that said, let's get back to this question. Again, we're taking 2x squared plus 3x minus 7, and we're adding to that 3x squared minus x minus 10. So the trick to this one is to identify like terms and combine them. Like terms have the same variable raised to the same power. So again, like terms have the same variable raised to the same power. Let's start with this 2x squared. We have the variable x raised to the second power. So if we look through the rest of this equation, we can see that there's an x raised to the second power right here. So this is 2x squared plus 3x squared, which becomes 5x squared. And now that we've combined those like terms, we can go ahead and cross them out. Next, we have 3x. Again, that's x raised to the first power. And the only other like term in this expression is right here, negative x. 3x minus x is 2x. All right, let's go ahead and cross those out. And then we have negative 7 and negative 10. Negative 7 plus negative 10 is negative 17. And just like that, we added those polynomials, and we can see that matches answer choice D in this case. All right, so number 5 here says if C is 30, then what is F? Use C equals 5/9 times Fahrenheit minus 32. C refers to Celsius and F refers to Fahrenheit, so we're making a temperature conversion in this problem. So I'm going to start, not surprisingly, by copying down the formula that was given. Celsius equals 5/9 times Fahrenheit minus 32. All right, so we're told what C is. We're told C is equal to 30, and we want to solve for F. That is, we want to get F equal to something by itself. So this is going to require some skills with algebra to solve. And if you struggle with the algebra behind solving one of these problems, check out my video called Converting Fahrenheit to Celsius. or my video called Converting Celsius to Fahrenheit. In those videos, I show you everything you need to know to answer these conversion questions correctly. But that said, we're going to start by plugging in 30 in place of C. So this is 30 equals 5/9 times Fahrenheit minus 32. All right, we're solving for F. And as we can see, it's stuck in these parentheses over here. So the very first thing I'm going to do is clear this fraction of 5/9, which means I'm going to multiply it by its reciprocal of 9/5. And I have to do that to both sides of the equation here. This 9 and this 5 cross out, which leave you with just F minus 32 over here. But that said, now we have to deal with this. 9/5 times 30. Let me go ahead and deal with that off to the side. We have 9/5 times 30. As you can see, we're multiplying a fraction by a whole number. Well, we can write 30 as a fraction by placing it over 1, and that enables us to reduce this like this. We could say 5 goes into 5 one time, 5 goes into 30 6 times. Now we have 9/1 times 6/1. So 9 divided by 1 is 9. 6 divided by 1 is 6. Of course, we should be able to do 9 times 6 in our head. That's going to be 54. So 9/5 times 30 is the same thing as 54. Again, now we're just solving for F, so we're going to add 32 to both sides now. This crosses out here, leaving you with just F on this side. We have 4 plus 2, which is 6, 5 plus 3, which is 8. So F is 86, which is answer choice C. In other words, if it's 30 degrees Celsius outside, that's the equivalent of being 86 degrees Fahrenheit. All right, so that's that one. Number 6 here says the coordinates of point A and B are 5, 10, and -5, -10 respectively. What is the slope of the line that connects the 2 points? So in this case, we're going to have to use the equation to find the slope of a line, and that's m, which stands for slope, equals y2 minus y1 over x2 minus x1. As a matter of fact, this is the very first formula on my reference sheet. Okay, so make sure you know this one. And now you might be saying, where do I get x1, y1, x2, y2 from? Well, those are the values of your ordered pairs. Again, this is x1, this is y1, this is x2, this is y2. All right, so now let's just plug those values in accordingly. Again, y2 is -10, so this is -10 minus y1 is 10, so -10 minus 10. X2 is -5, so this is -5. X1 is 5, so -5 minus 5. And let me scroll down a little bit here. -10 minus 10 is -20. -5 minus 5 is -10. All right, so we have a negative divided by a negative. A negative divided by a negative is going to be a positive. 20 divided by 10 is 2. So the slope in this case is positive 2. I recently created a video on how to add, subtract, multiply, and divide positives, negatives, 0, and 1. So if you struggle with knowing that a negative divided by a negative is a positive, you need to check out that video. I think it's got almost 10,000 views. So a lot of people seem to struggle with that idea. All right, so number 7 here says, which of the following is not a prime number? We have 7, 41, 44, 97. Let me say this. Because I understand prime numbers and how to perform divisibility checks on numbers, I already know what the answer is. So if you haven't watched my video on prime numbers and divisibility rules, you need to do so, because these problems will become so easy that you'll look at the numbers and say, oh, yep, this one's not prime. All right, and let me show you how you do that. So we're given these numbers 7, 41, 44, and 97. Again, a number is considered prime if it's only divisible by 1 in itself. In other words, if a number is divisible by 2, 3, 4, or 5, then it's not prime. And we're going to run divisibility checks on these numbers. And if they are divisible by 2, 3, 4, or 5, then they're not prime. Well, how do you determine if a number is divisible by 2? How do you do that very quickly? Well, you look at the number. If the number's even, it's divisible by 2. If the last digit of the number's even, then it's divisible by 2. So with that in mind, let's run our divisibility checks for 2 here. Is 7 an even number? It's not, it's odd. So we know 7 is not divisible by 2. Is the last digit in 41 an even number? No, it's odd, it's 1. So 41 is not divisible by 2. What about 44? What's the last digit of 44? It's 4. 4 is an even number. So I know 44 is divisible by 2, which means 44 is not prime because it's divisible by something other than itself and 1. All right, so watch that video on divisibility rules and prime numbers. I guarantee you it's going to help you on test day. All right, so that's that one, and that's all there is to it. I mean, I instantly knew 44 was divisible by 2, and therefore it wasn't prime. All right, so number 8 here says, find the product of the reciprocals of the following. We have 6, 1/10, and 3 1/5. So we have 6, 1/10, and 3 1/5. And we want to find the product of the reciprocals. Well, first we have to know what a reciprocal is. And a reciprocal means simply exchange your numerator and your denominator. Well, what about 6? 6 is a whole number. Well, in this video already, we've written a whole number as a fraction by placing it over 1. So the reciprocal of 6, which is the same thing as 6 over 1, is 1/6. So that's one reciprocal. What about 1/10? Again, we're just exchanging our numerator and our denominator. So the reciprocal of 1 over 10 is 10 over 1. And now we have this mixed number, 3 1/5. Well, first things first, we have to write this as an improper fraction. And we do that like this. We keep this denominator the same. And then we do 3 times 5, which is 15, plus 1 is 16. All right, so what is the reciprocal of 16 over 5? Again, we're just going to exchange our numerator and denominator. So this becomes 5 over 16. And again, now that we found all the reciprocals of these numbers, we want to find the product of these reciprocals. So this problem becomes 1 over 6 times 10 over 1 times 5 over 16. That is to say, we're multiplying these fractions together. And when you multiply fractions, all you really do is multiply straight across. There's no real tricks to it. So this becomes 1 times 10 times 5 over 6 times 1 times 16. Let's go ahead and work this out. 1 times 10 is 10, times 5 is 50. 6 times 1 is 6, times 16. Well, I can't do that in my head, so I'm going to have to work it off to the side. This is 16 times 6. 6 times 6 is 36. Carry a 3. 6 times 1 is 6, plus 3 is 9. So this is 96. And of course, we can reduce this by dividing 50 as well as 96 by 2. 50 divided by 2 is 25. 96 divided by 2 is 48. Can't do that in your head. I'll work it off to the side here. We have 96 divided by 2. How many times does 2 go into 9 without going over? Well, that's going to be 4 times. 2 times 4 is 8. 9 minus 8 is 1. Drop down our 6 here. 2 goes into 16 8 times without going over. 2 times 8 is 16 with no remainder. And we can't simplify this any further, so our answer in this case is 25 over 48. All right, so that's that one. You absolutely have to know about reciprocals in order to be successful on the ASVAB. Again, I recently created a video on that, so make sure you watch it. It will help you tremendously. I keep saying that for all these questions, but it's true. So, all right, so number 9 here says, if 3 raised to the x power equals 81, then x equals. All right, so let's copy this one down. We have 3 raised to the x power equaling 81. This is a bit of a tricky problem because we're trying to figure out what x is. We want to know 3 raised to what power will give us 81. Well, let's think about it this way. What is 3 squared? 3 squared is the same as 3 times 3, which is 9. What is 3 to the third? 3 to the third is 3 times 3 times 3, which is what? 3 times 3 is 9 times 3 is 27. What about 3 to the fourth? That's the same as 3 times 3 times 3 times 3. Well, 3 times 3 is 9 times 3 is 27. What is 27 times 3? 7 times 3 is 21, carry a 2. 2 times 3 is 6, plus 2 is 8. So 3 to the fourth is 81. And as we can see, if we raise 3 to the fourth power, it's going to be 81. Therefore, we know x is 4, which is D in this case. All right, so that's that one. Nothing too difficult there. A lot of people get intimidated by these problems, but they're pretty straightforward once you know what the question's asking. All right, so number 10 here says, what is the length of the diagonal of a rectangle that has a base of 8 and a height of 6? All right, so first things first, let's draw a rectangle. All right, there's our rectangle, and according to the problem, we know it has a base of 8 and a height of 6. Well, as far as rectangles go, we should know that if this side's 8, then this side's also 8, and if this side's 6, this side's also 6. According to the problem, we want to know the length of the diagonal of this rectangle. Well, what is the diagonal of this rectangle? It's the distance from here to here. And when you draw a diagonal across a rectangle, you actually create 2 right triangles. And how can we use this information about right triangles to find the length of the diagonal of this rectangle? Well, let's go ahead and pull out one of those right triangles. Let me do that over here. All right, so this is this right triangle, so we know this side's 6 and this side's 8. And what is this part of a right triangle called? It's called the hypotenuse. Can we use something that we know about right triangles to find this hypotenuse, which is the same as the diagonal of this rectangle? We can. It's called the Pythagorean Theorem. And that says a squared plus b squared equals c squared, where a and b refer to the legs of the right triangle, and c refers to the hypotenuse of the right triangle. Well, the hypotenuse is always easy to identify. It's directly across from the right angle. So I know this length of this triangle is C. And likewise, I know 8 and 6 are the legs of this right triangle. So I can let B be 8 and 6 be A. So all we have to do is plug those values in accordingly and solve for C. As you can see, C here is the same thing here. So once we solve for C, we'll know the length of this diagonal. So A, I let be 6, so this is 6 squared, plus B, which is 8, so this is 8 squared, equals C squared. 6 squared is 36. 8 squared is the same as 8 times 8, which is 64, equals C squared. All right, 36 plus 64 is 100. And if you can't do that in your head, I'll work it off to the side very quickly. We have 64 plus 36. 4 plus 6 is 10, so we're going to bring down a 0 and carry a 1. 6 plus 3 is 9, plus 1 is 10. All right, we don't want to solve for c squared. We want just c by itself. So now we're going to take the square root of both sides. This will cross out, leaving you with just c on this side. And the square root of 100 is 10. So c in this case is 10. So that means the length of this hypotenuse is 10. And the length of this hypotenuse is the same as the length of the diagonal of this rectangle. So this is also 10. So the answer to this one is C, 10. We had to use the Pythagorean theorem to figure that one out. All right, so that's that one. All right, so number 11 here says, if the perimeter of a square is 64 feet, what is its area? All right, so first things first, let's make a square here. And it doesn't have to be perfect. Squares can be hard to draw sometimes. And what do we know about squares? Well, in squares, all the sides are equal. So this side's equal to this side, and that side's equal to that side, and finally that side's equal to that side. We're told the perimeter of this square, or P, is 64. All right, so we're told its perimeter, and we want to find its area. So first things first, we have to figure out the measurement of one side of this square. So the question is, how are we going to do that? Well, to find the perimeter of a square, you would simply add up all of its sides. Those are currently unknown, so I can call this side x, which means this side's also x, this side's also x, and this side's also x. So to find the perimeter of this square, I would do perimeter equals x plus x plus x plus x. We know what the perimeter is. P is 64. So I'm going to replace this P right here with 64. So this becomes 64 equals, what is x plus x plus x plus x? Well, that is 4x. Those are all like terms. Now we're just solving for x now. So we're going to divide both sides by 4. This will cross out here, leaving you with just x. 64 divided by 4. If you can't do that in your head, you can always do the long division. 64 divided by 4 looks like this. 64 divided by 4. Let me move up a little bit so you can see that. We start by asking ourselves, how many times does 4 go into 6 without going over? That's going to be 1 time, given that 4 times 1 is 4. 6 minus 4 is 2, and we drop down this 4 now. How many times does 4 go into 24 without going over? Well, 6 times 4 is 24 with no remainder. All right, so x in this case is 16. All right, so we know the length of the sides of this square. We have a square that looks like this. 16 by 16 by 16 by 16. Well, how do you find the area of a square? An area of a square is always side times side. So we know what those sides are. This becomes 16 times 16. All right, so all we have to do is work that out. I'm going to do that off to the side. 16 times 16. 6 times 6 is 36, so we're going to drop down a 6 and carry a 3. 1 times 6 is 3 plus 1 times 6 is 6 plus 3 is 9. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 6 is 6. 1 times 1 is 1. 6 plus 0 is 6. 9 plus 6 is 15. Carry a 1. 1 plus 1 is 2. So the area of this square is 256 feet squared, which is answer choice A in this case. Let me say this. On the ASVAB, you should expect to know how to solve a problem involving the relationship between the perimeter of a square and its area. So make sure you can work these problems out. Chances are very high that the numbers will change, but the way you solve them does not change at all. So make sure you can work those out. All right, number 12 here says, what is the height of a triangle that has a base of 8 and an area of 16 square feet? All right, so if it's helpful, you can make a diagram of a triangle. And in this case, we weren't told what type of triangle we're dealing with. So I'm just going to draw a nice right triangle here. And we're told the base of this triangle was 8. And we want to know what its height is. All right, so to find the area of any triangle, use the formula area equals 1/2 base times height. In this case, we were told our base is 8 and our area is 16. So let's plug those two things in. Again, we're told area is 16, so A is 16. So this becomes 16 equals 1/2. We know our base is 8, so this is 8 times height. Again, we're trying to solve for height. Given that we're trying to solve for height, we're ultimately solving this equation such that we end up with h equal to something by itself at the end. All right, so let's go ahead and work this out. This becomes 16. What's 1/2 times 8? 1/2 times 8 is 4. So 16 equals 4h. Let's divide both sides by 4 now. This crosses out, leaving you with h over here. 16 divided by 4 is 4, so we can see h equals 4. All right, that's all there is to this one. Again, you just had to know the area or the formula to find the area of a triangle and go from there. Pretty simple problem. All right, so number 13 here says the area of one circle is 4 times as large as a smaller circle that has a radius of 3 inches. What is the radius of the larger circle? All right, so in this case, we're comparing two circles. So let's go ahead and draw two circles. We have a smaller circle here and a bigger circle that has an area that's 4 times as big as the smaller circle. We're told that the radius of this smaller circle is 3 inches. All right, and we want to know what the radius of this bigger circle is. All right, so let's get started by finding the area of this smaller circle. To find the area of circles, use the formula area equals pi r squared. We know what r is in this case. R is 3, so let's plug that in accordingly. This is area equals pi 3 squared. Area equals, what's 3 squared? That's going to be 9, so this is 9 pi. Well, what do we know about this bigger circle? Again, we're told the area of this bigger circle is 4 times the area of the smaller circle, which is 9 pi. All right, so let's plug in 9 pi there. All right, we're going to keep this in mind as we work out the area of this bigger circle. Again, this is its radius. To find the area of a circle, use the formula area equals pi r squared. We know what the area of this bigger circle is. It's 4 times as big as this area of the smaller circle. What is 4 times 9 pi? Well, 9 times 4 is 36, so it's 36 pi. So we know A in this case is 36 pi equals pi r squared. Again, we just want to know what the radius is. We want to get r equal to something by itself. So the first thing I'm going to do here is divide both sides by pi. This will cross out, leaving you with r squared over here. And we can cross out these pi's now. This is 36. Now we're just solving for r, so we want to get rid of this square by taking the square root of both sides. This crosses out, leaving you with just r. R equals the square root of 36, which is 6, so r equals 6 in this case. So we know the radius of this bigger circle is 6, which is B. All right, so that's that one. Pretty tough question. Make sure you know how to find the area and circumference of circles. Those questions appear frequently on both the ASVAB as well as the PiCAT. So number 14 here says if 4 exclamation point, and you read that as 4 factorial, is the same as 4 times 3 times 2 times 1. Simplify the following expression. 12 factorial divided by 3 factorial times 10 factorial. All right, so this question tells you exactly what a factorial is. Factorial means take the number that's given, in this case 4, and you multiply it by everything less than 4 until you get to 1. So as another example, 5 factorial is the same as 5 times 4 times 3 times 2 times 1. All right, so let's go ahead and apply that to our expression here. Again, the expression we were given is 12 factorial over 3 factorial times 10 factorial. All right, so let's expand this out. We have 12 factorial in our numerator, so that's the same as 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's all going to be over 3 factorial, and I'm going to put these in parentheses, 3 times 2 times 1 times 10 factorial. That's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, so if you work all this out, you're doing something wrong because you can simplify this very quickly. I can cross out this 10 and this 10, this 9 and this 9, this 8, this 8, this 7, this 7, this 6, this 6, 5, 4, 3, 2, 1. And when I do that, I'm left with this 12 times 11 over 3 times 2 times 1. All right, and now this problem becomes very simple. 3 times 2 is 6 times 1 is 6. That said, some of you probably can't do 12 times 11 in your head, so let's do it off to the side. We have 12 times 11. 1 times 2 is 2. 1 times 1 is 1. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 2 is 2. 1 times 1 is 1. Let's add these together. 2 plus 0 is 2. 1 plus 2 is 3. And 1 plus nothing is 1. So this becomes 132 over 6. And again, we can regard fractions as long division by reading them like this. 132 divided by 6. So that's 132 divided by 6. And the question becomes this. How many times does 6 go into 1 without going over? It doesn't. How many times does 6 go into 13 without going over? Well, that's 2 times, given that 6 times 2 is 12. 13 minus 12 is 1, and we drop down this 2. How many times does 6 go into 12? That's 2 times. 6 times 2 is 12. 12 minus 12 is 0, so there's no remainder. 132 divided by 6 is 22. And we can see that's answer choice D in this case. I do have a video on factorials. I work out many of these examples in that video. So if you struggle with factorials, go check out that video. This topic does sometimes show up on the ASVAB. All right, so number 15 here says graphs of the following equations are straight lines except. All right, this problem's a little tricky because most people who learn about straight lines don't really pay attention to some important things. There are a couple equations of straight lines. There's slope-intercept form, which is y equals mx plus b. And then there's standard form, that's ax plus by equals c. These are two generic equations of lines. And what do you notice about these equations? There's no power on this y, there's no power on this x, there's no power on this x, there's no power on this y. So any equation in which there's a power on x and y is not a straight line. So in light of that, we know this is not a straight line, whereas all the other ones have no powers on their x's and y's. All right, so kind of a trick question, but nothing too difficult. Again, for an equation to be an equation of a line, it has to have x and y with no powers on them. If it's raised to the squared or raised to the third power, fourth power, fifth power, that is not the equation of a line. So for example, y equals x squared. The graph of this is a parabola that looks like that. All right, so that would not be a straight line. All right, so that's all there is to that one. All right, so number 16 here says solve the equation for C. We can see we have A equals to A plus B plus C plus D, all lowercase, over 4. All right, so this is an example of solving a literal equation. So let's start by copying down the equation. We have A equals A plus B plus C plus D over 4. And we're trying to solve for C. In other words, we want to get C equal to something by itself like that. So we're going to have to rearrange this equation such that we get C by itself. And the first thing I'm going to do is get rid of this 4 by multiplying both sides by 4. This will cross out here and here. And this becomes 4A equals A plus B plus C plus D. And now it should be obvious that to get C by itself, we'll just move A, B, and D to the other side via subtraction. All right, so this will cross out here, here, and here, leaving us with just C on this side. And we can see this becomes 4A minus B minus D. So C in this case is 4A minus B minus D, which is answer choice C in this case. All right, so that's it for this video. I hope you found it helpful. Let me stress this again. While you probably won't see these exact questions on the ASVAB or PiCAT, you do have to know these formulas and techniques in order to be successful on both of those tests. If you like the content I'm creating, please consider subscribing to my channel. And as always, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.
Konnichiwa.